Assalamualaikum and hello. In this video, our group will be presenting our item that we have chosen to invent for this assessment, which is a fan. In this presentation, we will discuss the relationship between fans and the two theory which are rotational motion and thermophysics. We will also explain the component of the need and approach. Okay, first, let's talk about rotational motion. The motion of a fan is rotational, which means that the blades of the fan rotate in a circle around a fixed central point. In terms of thermal physics, a fan will draw in hot air from its surroundings, accelerate it and push it downward into the room as a cool breeze. Next, for the fan we have decided to use plastic for the blades. This is because plastic can be molded into various shapes, resistant to rust, easy to maintain, lightweight and more silent. Additionally, the blades of the fan is designed with an airfoil which is more efficient and can be used in medium to high pressure industrial application. This fan is suitable for domestic use at home as it improves the efficiency for airflow in the entire house. Other than that, it easily molded in shape characteristic makes a high quality aesthetics. The fan is also ideal for use in school due to its quiet operation, which is appropriate for library and classroom settings. Moreover, it is more affordable to apply in every room at school. Next, fans tend to encounter problem after 3 or 5 years of usage. The lifespan of a fan is usually determined by the frequency of its use. On average, a ceiling fan can last for 6 to 8 years, while standing fan can last up to 3 to 5 years. However, if the fan is not clean and checked regular, this can decrease its lifespan. Typical people only experience fan problems once it has been in use for many years. About 7 out of 10 people who complain about the same problem, such as noisy, which can be caused a loose part of a damaged motor. Fan speed issues are also common and may be caused by the switch of a capacitor. Additionally, a fan may wobble or shake due to an unbalanced blade or a loose screw. Some users may face significant issues due to a faulty fan, such as excessive noise that can disrupt their sleep, while some individuals may not be affected by the sound.
Right, now we're going to talk about the problems. Right, time of people experience the problem, and that problem that usually occurs are noise issues, fan speeding issues, and wobbly or shaking fans. Right, the big problems for users or customers are excessive noise that will keep users awake at night. This is a major problem. Why? Because of the noise that the fans produces might disturb the sleep of the users, and even worse, it might, if they are parents and they have little children, little babies with them, it might even awaken their babies from their sleep and messing up their sleep schedule. And the next one is a fan that is unsteady or trembling that may be hazardous if it is not fixed or replaced. And like if the fan is put on a high place, for example, a table, and the fan shakes too much, trembling, it might even fell off from the table and crashing to the user's face when they are sleeping, resulting in unwanted injuries. That is one of the biggest problems uh, of the fans. All right, now I'm going to talk about key problems if need is not met. Right, the blades made from plastic are not preferable at extreme temperature. Why? Because it cannot be used for industrial purposes. Why? Because plastic is not a material that can withstand high temperature surrounding. If it's in industrial places, like the surrounding might be the temperature of the surrounding might be too high for the plastic, resulting in the plastic maybe melting or becoming soft, and that will result in unwanted accidents and injuries. That's why it's not preferable at extreme temperatures or for industrial purposes. And the second one is higher costs of production of the airfoil fan blade. Lower sales and will cause a big loss to the manufacturers. Why is it? Why will it result in lower sales? Well, because of the higher production cost of production, we have to sell this product at a higher price in the market, uh, resulting in buyers not wanting to buy it because of its price, high price. They could find uh, a reasonable price of the product in other brands or like other materials like plastic fan blades, plastic blades. Right. That's why it will result in lower sales, and lower sales will cause a big loss to the manufacturers because of no one wanting to buy your products, but you keep on producing it with high costs, but no one wanting to buy it, resulting in a big loss. Even worse, it might even result in you announcing bankruptcy. Right, now we're going to the approach section, where we're going to talk about our unique approach to meet this need. The first factor to of our approach or of our unique approach is rotational motion, and the second one is thermal physics. These two factors are the most important approach for us to meet this need. Like for the rotational motion, we use the aerodynamic blade design and also enhance airflow efficiency to make it less wobbly, and also making the air blow from the fans even stronger than the rest of the products in the current market. And for the thermophysics factors, we make use of the heat dissipation mechanism and also portable power management, where the concern of users are like using the fans for too long, making the motor of the fans overheat. Why? Because the motor, when they move for too long, it will become hotter and hotter and hotter, and resulted in overheating. In even worse case, it might even explode. The fan might even explode. That's why we want to avoid it by making use of the heat dissipation mechanism, making the heat of the motor dissipate quickly, and not reaching the overheating state. This will make the motor of the fans cool down a lot faster than the rest of the products in the current market. All right, what is our solution? I'm going to talk about it. Now, the rotational motion factors. We're going to optimize the fan overall design, including shape of the blade, pitch, and angle. This will help the fan become more more stable and less wobbly, making it safer for the users, and also making the airflow of the fans even stronger. For the thermal physics, for the thermal physics factor, using integrating efficient heat dissipation mechanism and also implementing a power management system. Right. Uh, by making the heat dissipation mechanisms more efficient, like I said from the last slide, it will make the motor more cool and never reaching the state of overheating, making it safer. And also by implementing a power management system, the power consumed from the fans will become less. We could even say it like save more energy and more energy efficient from the rest of the current product in the market. Like we all know, like the sticker on the products on some products where they show like the how many stars are there for the efficiency of the energy used. Like we're targeting to make it 5 stars, right? Making it 5 stars, which means it will be so much efficient in using the power. Right. Do you have any technical issues to solve? Yes, we do have some technical issues to solve, and that is motor efficiency. Why? Because we our current products and our products also are facing the problems of energy loss and overheating. But don't worry, we are trying to overcome these issues by selecting motor with minimal energy loss and high power efficiency. This one will make it the motor more efficient in consuming power, where it won't consume too much power, but even though it's using, for example, it's using this much power, but it consumes this much power. This isn't an efficient motor. That's why we're selecting motor with minimal energy loss. But even though it's using this, we're targeting the motor to be this much in using energy in energy loss, but high power efficiency like this much power efficiency. And for the overheating issues we are facing, we are trying to use the effective heat dissipation, right, to improve heat transfer and cooling. Like I said from before, the overheating problem is a major problem to all products, where if overheating too much, it will even leads to explosion. That's what we're trying to improve so that our products don't result in the same don't result in the same problems as the other products in the current market where they explode if overheating. That's why we use this. We're trying to solve this by effective heat dissipation. Like I said, making the heat from the motor dissipate even more efficiently.